Now what we will do is we will grocery items that I have. Okay. So that is the simplest thing that we can think of. So what do you do when you want a list of grocery items? You know, name all of them and put them together and say, okay, these are grocery items, and send it to your shopkeeper or call your shopkeeper and say, please deliver these items for me. So when you are looking at an edit, it is an unordered sequence of 0 or more elements of a particular given element type. What is my element here, type here in this particular example of grocery items? Its element type is grocery items. So what do I have? I have elements A1, A2, A3, AN. N is generally greater than or equal to 0, and AI is some particular type. N is the length of my list in this particular example, grocery list, let us say. N greater than or equal to n, first element is A1 and last element is AN. Now what are the things that you would like to do in an ADT list? So when you want to define an ADT list, what we would, a list of people, for example, I can have a list of students who are interested in music, list of students who are interested in sports, so on and so forth. It can be any kind of list for that matter. What are the things that we would like to do? I would like to, perhaps when I have this particular list, I would like to insert elements into the list. I would like to find the end of the list because I would like to know how many people are there. I want to find suddenly, I have signed up for, let us say, a game, and I have registered for playing tennis or something like that. Then suddenly I do not want to play tennis, so I want to cancel my registration. Then I want to locate a particular element in the list, and I want to find out who is there at position X, because I would like to, let us say, this is an unordered list, and IIT is saying that all these people who are registered for the hostel, you are going to put two people together. Then maybe I would like to find out at my position who is going to be my neighbor. I would like to find out who my neighbor is, and as I already said, I deregister, let us say, from a game or whatever it may be. I want to delete the element from the list, and then I find out who is next, who is previous, and so on and so forth. So all these operations, if I want to perform on the list. We have not yet talked about how the list is going to be implemented. We will do that a little later. So what we are first defining is, we define an ADT list, and this tells me what operations go into the ADT list. We first create an empty list, then you insert into the list at a particular position, then you delete elements at a particular position. You can locate whether a particular element is in the list. You retrieve, the retrieve element at a position P, find the next element of position P, previous element of position P, print the entire list, find out what is there at the first of the list, what is there, get the position of the first element in the list, get the position of the last element in the list, and so on. So now how do I implement a list? Now what we do is, it could be implemented using either an array or a linked list. These are the basic two data structures that are available. We already talked about it in the last class. An array is basically enables random access, whereas we already said a linked list on the other hand is a recursive data structure, and you have to start from the head of the list. So you can do the implementation of the list using either the array or the linked list, but the operations on the list are the same, and as far as the user is concerned, the user is quite oblivious to how the implementation of the list is being done. Okay. So this is essentially the idea, and as far as the user is concerned, he or she is only going to do insertions, deletions, so on and so forth. Okay. Let us see how this can be done. Alright. So what we do is, this is a implementation of the list which I am showing over here. So what do? I have a program called linkedlist.cxx. I have implemented this in C++, and notice that I have a recursive implementation over here. You can also use an array. Array is easier. Notice that I have basically, what is it that I am making available to the user? I am doing this type def position, which is the P in the implementation that we have over here. P corresponds to the position in the list over here. P is type def to something called to position, and essentially the user will say, get me an element at position P. Okay, that is the way you will look at it. So what does he or she do? So we have here private. Notice that I have done an implementation using linked list, and this is hidden from the user, and because it is defined as a private data type, then I have a facility to create a new list, then I have a facility to insert element X at positions P. So, element type is something that is specified by the user. Now, I am writing a generic list data structure which is internally represented as a linked list. Element type is provided by the user because the user knows what element he wants to, what set of elements he wants to put in the list. For example, is it a list of books, is it a list of plates, is it a list of grocery items, okay? Is it a list of students? It may be anything for that matter. That information comes from this element type defined by the user. Then what he or she will do is, essentially we have a implementation here. I have created, for my convenience, I create one empty node in the list. So, this is what I do. My empty list, make null for example, creates a list with one single element, okay, only one element is there, and it points to the next is made, I make a dummy header for that matter. Then when I am inserting, I always insert at the end of the list. What am I doing here? Notice that I want to insert at position P, I am inserting at P pointer next. This is again not known to the user. So, when the user asks me for an element at P, I will return the element at P pointer next. That is the point of all of this. Okay. Similarly, when I am doing deletion, the reason why I have done this dummy node is primarily because deletion becomes very easy. P pointer next becomes P pointer next or whatever it may be, and return will give you the, notice that please observe this over here, we are having position list end. So, as far as the user is concerned, he or she does not know whether position is a pointer to a like into a recursive list or it is a index into an array. So, because we have done the type def in the definition itself. Okay, going back to this, what have we done over here? We have done the type def here, and all that a user uses is uses position, okay, or in all his programs. So, it does not matter if as long as I can change the internal representation of position. Here it is pointing to a pointer, it could be 0 for example, corresponding to the index of the 0th element in first element in the array. It could be done that way too, but I have just used a linked list operation to do this. So, this shows the deletion operation and this shows the insertion operation. So, basically what is it that we are doing here? We are essentially creating a new element over here, inserting it, and then we store this pointer in a temporary variable and then put it back over here. Okay. So, if you notice how to find and what do we do over here? If you notice here again, let us look at the end over here. This is an interesting function. End, for example, returns the element. Notice that we are continuously while P pointer next not equal to not. So, it returns the actually the pointer to pointing to null at the end of the list. Okay. So, but the primary reason for this is that when I want to insert, I can very easily insert at the end of the list. Okay. P pointer next is null in that particular case. Okay. So, this is the list and I want to leave you with a set of operations. I didn't put this here. Okay, let me get back to this. I think I have lost the picture over here. Now, what are the applications of lists that you can do? Let me give you an example. I thought I had it here. We can do things like you can create a list with of let us say of using, let us say I want to have sets for which I want to perform S1 union S2, S1 intersection S2, S1 minus S2. All these can be implemented using lists. Okay. Let me give you one example that I would. So, what would I do? I would create a list of elements. Let us say S1 is made up of the following elements. Let us say 4, 3, 2, 7 and 6 or something like that, and S2 is made up of 3, 2, 8 and 10. So, what would I do? I would create, I would say that if you remember here, I would say that going back to this, okay, I would say that my A comma B or S1 comma S2 are of type list first. Then what I will do is, I am reading, let us say, this input from somewhere, and so I would have while I less than or equal to N1, I equal to 1, let us say, I would say first of all, I would make a empty list. I would do S1 dot make null, and I would do S2 dot make null, which will create 2 empty lists. Then what will I do? And let us say N1 is the number of elements. I have got all these elements, let us say, in some array. Then let us say that I have an array A of elements 1 to N1, and I have an array B of elements 1 to N2, which need to be inserted into the list. So what I would do is, I would say now S1 dot insert, I would say here S1 dot end, because the end of the list, comma A of I, okay, I equal to I plus 1 end while. So in much the same way I would do for S2 too. So while again I will say I equal to 1, while I less than or equal to N2, S1 dot insert S1 dot end, comma, I am inserting at a position B of I equal to I plus 1. Okay. So now what have we done now? We have created 2 lists, S1, sorry, let me call this S2 over here, S1 and S2, into which we have inserted elements into the list. Okay. Now next what we want to do is, we want to find the union. Union means what now? I have to look at the union of these 2 sets is what? A set is always made up of unique number of elements. So when I look at S1 union S2, clearly what do we require now? S1 union S2 should be made up of the elements. What do we have to do now? It should consist of 4, 3, 2, 7, 8, 6, 10, something like this, right? I am keeping it unordered here. So what does it mean? It only should consist of unique elements. That is the definition of a set. So what we could do is, we could start off with set S1, then we know where the elements in set S2 are, and till the end of the list, take all of them, just insert it at the end of S1. We could do that. So what would I do now? While I less than or equal, I have already done this over here. So I can start with I equal to 1, and while I less than or equal to N2, what am I going to do? I am going to say S2 dot retrieve. What will I do first? P is a position of the first element, S2 dot first gives me the first element. Okay. And what do? We retrieve, sorry, I should put this outside over here. P is equal to S2 dot first. Then I will retrieve what is there at P, and we will insert into S1, S1 dot insert, S1 dot end, comma S2 dot retrieve at position P. What is the meaning of this? I am inserting the element at position P from S2 to the end of the list S1. So I would do this. So now what will I do? I will say update P, P is equal to S2 dot next of P. Okay, I can get the next position and so on and so forth. I would do this. So this completes. So what does it do now? Basically, this will give me a new list such that I have 4, 3, 2, 7, 6, 3, 2, 8 and 10. So clearly it does not satisfy the definition of a set where all the elements have to be unique. Next what I can do is, I can say take this new list that I have, I can write another function which takes as argument a list. I can say list S, purge the duplicates in a list. I can write a separate function for that. So what does it that mean? I take this list here, find out, I go through traverse the entire list, see if the element is found. If that element is found, I delete that element. Okay, that is, if there are duplicates in the list, I simply keep on deleting it. That is, I start with this position, start with the first element, then traverse through the entire list over here. I can go to the end of the list, see if that element is repeated. If it is repeated, repeat the duplicate, then go to the next element and so on. Okay, so you can do this. So list is, notice that what is interesting is, I want you to see this particular segment of code here which I have written. I have not simply, I do not even know what the implementation of the list is. It may be an array implementation, it may be a linked list system implementation. A and B are arrays which I have provided, which the user has provided with the data in them of type element type, and all that I am doing is insert at the end. Okay? So this is the most important criteria about abstract data types, where we use only the operations. We know that just like we have integer, what have we done here? S1, S2 corresponds to a abstract data type called list, and what is it that we are doing now? Into that list we are inserting elements. Where are the elements coming from? From a user defined array. He is doing it, he or she is doing it himself. So what is he doing? He is saying insert it at the end of the list. We are not bothered, because initially what is going to happen? I said create an empty list. It creates an empty list, but it creates the empty list. Where is the end point to? End points to the first dummy element that I have in my implementation, and I am saying okay, enter the list, just keep on appending these items. That is what it does. Similarly, that is done, another list is created and we have done this. Then to form union, what are we doing? We are first putting all the elements of S2 at the end of S1, so it forms the union. Okay, but the problem is it may not have uniques. Then what I do? I write a separate function called purge, which will simply delete the duplicates. How do I perform purge? I start with the first element, check what is there at the first element, and see if you can locate that particular element in the rest of the list. If I can locate the element in the rest of the list, if it is already there, then I delete that element at that particular position. The important point, I simply do not need to know what the implementation of the abstract data type list is. Okay? So I would like you to go back and try the other operations. In particular, I have not given you this implementation of purge. I want you to think about this. I have talked about union. I would like you to think about complement and intersection on sets where the set is represented using a list. I would also like you to think of how can you use only the list operations to order the elements in the list. Okay? So when you are ordering the elements in the list, what do I need? I need something to compare, because an order means putting in ascending order, putting in descending order. If it is integer or real, I can do it. Suppose it is names of people, how do you want to order them? Okay? So the comparison operation is provided outside the list implementation again, and just like here, to locate the element we are doing a comparison. The comparison is provided by the user. Okay? So let me stop with this list ADT, and next we will look at stacks and queues.